Good afternoon. Continuation of this previous video. For example, the observer is looking at a tree 15 meter high at a distance of 100 meter. If h is the height in millimeter of that particular object in a retinal image, the geometry of this figure that yields the 15 divided by 100, that is 15. Just note it down. 15 is the height, so this h divided by this 17, or h is equal to 2.55 mm. Here this C, that is the 17 mm, which shows the eyes, that is the iris recognition, iris, that is the human structure eye, and it has been there. So this 15 meter, this whole long, which has been divided by that height, distance of that particular person who is standing away from that particular image. Light and the electromagnetic spectrum. Here this Isaac Newton discovered that even a beam of sunlight is passed through a glass prism. The emerging beam of light is not white but consists instead of the continuous spectrum of colors ranging from violet at one end and red at the another end. The electromagnetic spectrum, this has been seen from the right from the school days and all, like when any light it travels through any spectrum, means then this energy of that one photon is that's electron volts. It is varies from 10 to the power of 6 to 10 to the power of 9. This range has been taken, and the frequency is, it has been denoted as hertz, and 10 to the power of 21 to 10 to the power of 5 it has been reduced, and this wavelength meters is 10 to the power of minus 2 to 10 to the power of 3 here. Here this is called as the hard X-rays and the ultraviolet, infrared, and then radio waves. Radio waves has been that is according to the hardness of the thing it has been allocated, and this gamma rays and soft rays, visible spectrum, and microwaves is from the right to left side it has been there. So the range is particularly from ultraviolet to infrared from 0.42 into 10 to the power of minus 6 to 0.7 into 10 to the power of minus 6. That is in the range of violet, blue, green, yellow, or orange, and then red. So this is like RGB, this is the main and major part of that color. So mixing of this color will get any of the color. So that is what in image processing techniques or image digital image processing, whatever it is, like here and all there, this RGB image, that is from grayscale. After that we will be moving to the RGB. The next one is the electromagnetic spectrum can be expressed in the terms of wavelength, frequency, or energy. This wavelength has been L and the energy N and are related by an expression where C is the speed of light, 2.998 into 10 millisecond. The energy of that particular electromagnetic spectrum is given by the expression capital E is equal to H into V, where here H is the Planck's constant. The simple image formation model is this pages by two-dimensional function of the form is f of x comma y. The value of the or amplitude of f at spatial coordinates is x comma y, which gives the intensity, that is the brightness of the image at that point. A light is the form of energy, that is f of x comma y. It must be non-zero and finite. The function f of x comma y may be characterized by two components, that is, one, the amount of source illumination incident of the scene being viewed. The second one is the amount of illumination reflected by the object in that particular scene. These are called as an image illumination and reflectance components, and are denoted by I of x comma y and R of x comma y. That is the illumination of that particular two components has been divided, like it has been components is or is I of x comma y, and that particular reflectance is denoted as f R of x comma y. The two functions combine as a product to form f of x comma y. This f of x comma y is equal to I of x comma y and R of x comma y. This is called as total absorption and then total reflection. Here the intensity of a monochrome image f at any coordinates f of x comma y, the grayscale level of L of that particular image at that point is, that is L is equal to f of x naught comma y naught, that is L lies in the range of L minimum, which is be less than or equal to L, as less than or equal to L maximum. In practice, this L minimum equal to I minimum and then R minimum, and IL max is equal to I max and R max. The grayscale images, the interval L minimum and L max is called the grayscale. The common practice is to shift this interval numerically to the interval 0 comma L minus 1, where L is equal to 0 is being considered black and L is equal to L minus 1 is considered white on the grayscale. All intermediate values or shades of gray value from black and white. The remaining things we'll see in the next video. Thank you.